Today, September 10th, we are working on section 1-5, and it's three things involved in this little section. We're going to be doing the distribution property, and then we're going to be collecting like terms, and we're also going to learn about factoring. So there's a lot to learn in this little section. As far as distribution goes, it's quite common, and there's a very simple way to learn it, and I'd like you all to write this down. For any numbers, A, B, and C, A distributed onto B plus C is the same thing as saying AB plus AC, okay? And a lot of people, we're focusing on the board now. A lot of people do this. They put arrows here to indicate, okay, that you're distributing. A times B, A times C. And this is distributive property of multiplication over addition. Why do you think you call it over addition? What operation sign do you see here? Addition, right? It's multiplying when you do, the arrows indicate multiplication over addition. Over means these arrows are going over addition, literally, okay? So, AB plus AC. Now, a lot of people have no problem with that, but they get messed up when they see it like this. No need, no problem. The arrows can go this way too, like that, and like that. And you're going to get essentially the same thing. You're going to get BA, right, BA plus CA. And that, because of what principle, is equal to this? Does anybody know why we can write this instead of that if we want to?
Oh, commutative.
Commutative principle, right. BA is the same as AB. And CA is the same as AC. And if we wanted to, could we write AC plus AB? Is it commutative property over addition? We sure could. If we wanted to. If you really wanted to. Right, Pepper? Yeah. B and C, that's algebra. Using letters to represent numbers, variables, okay? That's what A, B, and C are in this case, okay? Because that could be any number. A, B, and C could be any number. And so what you've done is created a general principle. Now, specifics. This is an example. This is an easy one. I'm just going to put this red line here, just to show that this is separate from that. 3 times 2 plus 5 equals 3 times 2 plus 3 times 5. Again, if I do the arrows, I swing it over, and swing it over. 3 times 2 plus 3 plus 5 is equal to 6 plus 15, which is equal to 21. Just to check it, I could have gone 2 plus 5 is 7, and 7 times 3 is 21, just to show you that that is equal to this. Either way. Most of the time, you're not going to get something inside the parentheses that's going to add up like that. So you have to distribute it, and it's going to make it easier. Now, down here, see, for instance, you get x plus 2. You can't add x plus 2. We don't know what x is. It's variable. We don't know what number that's going to be. So what do? Yes?
Distribute.
The 3 onto the x, and then plus 3 times 2. And hence, we have 3x plus 3 times 2, which is equal to 3x plus 6. Notice I have the 3 in green, just to show you that this 3 kind of gets thrown across onto those two things. It distributes itself over those two things, okay? Now, going the other direction is what is called factoring, okay? This is distribution. The other way is factoring. So when you start with this, and you recognize that 3 is a factor, then you pull it out, and it ends up looking like this. Who's done factoring before? Almost anybody's done factoring. So, distributing is the inverse of factoring. The inverse. Because when you distribute, you multiply. 3 onto x, and then 3 onto 2 is equal to 3x plus 6. When you factor, you divide it out. You find that 3 is the common factor, and you divide it out from each of those terms. 3x divided by 3 is equal to x, and 6 divided by 3, 6 divided by 3 is 2, and that's what you're left with. 3 times x plus 2. All right? Any questions? We're going to go over here. You should all be taking notes. Anytime we are in the board, you write it in your notes. Have you been doing that? Please write it down.
Yeah.
Okay, we're going over here now. So, Frankie, you want to bring it up? Factoring. Please write these all down quickly. Okay. Yeah, what time is it?
3:20.
What time?
On my phone, it's just 2:30.
Okay. All right, we have only a couple more minutes. But anyway, we just did this basically. 3x plus 3y equals 3 times x plus y. What would we do for this? Because the 3 is common, right? We saw the 3 here, and it's a common factor, so we took it out. What would be the common factor here? Anybody know? 5 and 5 look like they're in common. Would it come out of here? Just one minute, please. This is a 5 too. 5 comes out of there, and it's equal to x plus 2y plus 1. All right. Your homework tonight is page 27 and 28, 1 through 63 odds. Collecting like terms. We're going to dive into this. This is the finishing of the lecture yesterday. It's all in section 1.5 or 1-5. To collect like terms, you have to know what they are. First of all, can someone read this out loud? George, what are like terms? Here's the definition.
Like terms have to have the same variable and degree.
Right, the same variable and degree. And degree means what, Cameron?
Exponents.
Right. Whenever you're not sure of the question, just look at the board, because I've usually written the answer down. In this case, here's the example. Read it out loud there, Austin.
3x squared plus 4x squared plus 8x plus 5.
Right. And this is my hand. This is hand actor this time. 3x squared plus, isn't it a nice hand? 3x squared plus 4x squared why are those two underlined in green?
Because they're the same, but with different whole numbers.
But exactly, these are called coefficients. They have different numbers
They're
in
like
front.
terms.
They're like terms because they have the same variable, right, Stephen White? And the same what?
Exponent.
Exponent, right? There you go. Now, what do we do now once we've identified our like terms, right, Sapir? We've identified the like terms, what do? How do we add them up or subtract them, Sapir?
Okay, well you have to put you have to separate the coefficients with the other numbers.
Exactly.
And you have to put pockets in. You have to put 3 plus 4.
Great, fantastic. And what happened to the x squared? How come there's only one of them? There were 2 of them there, and there's only one there.
Because one of them cancels out.
Not really. That doesn't cancel out. It's just that they're like terms, so we're actually adding 3 of these things to 4 of these things. Why do I call it these things? Because it could be anything. They could be xy squared, or it could be xyz to the 5th. Whatever it is, there are 3 of these and 4 of those, and they're the same. So we can add them together and get 3 plus 4, which is 7x squared. If I had 3 red cars, and then I got 4 more red cars, I would have how many red cars? 7 red cars. But if I have 3 red cars and 4 blue cars, how many red cars do I have?
3.
3. You don't have 7. It's not the same. So you have to have the same thing to be able to add them together. All right? One example was the dolphins and tigers. Okay, they're clearly not the same. You can't have a dolphin tiger. So you got it, right? At least not in the zoos I've been to. 3 dolphins, 4 tigers. How many dolphins?
3.
Right. How many tigers?
4.
Right. But if I have 3 dolphins and 4 dolphins come along and swim along with the pod, then what do I have? 7 dolphins. Are they called, what are dolphins together? They're called pods, aren't they? Yeah. They're down in the bay, in like Pacific Palisades and Malibu. You can see them down there. If you ever want to go down to the beach. In the morning, around 10 o'clock or 9 o'clock. Everybody go. All right. So that's it for this little blurb. On this kind of question, these are word problems. This is actually number 40 from your assignment 31. This problem says that D is the distance that Shannon runs, and Jane runs 1/3 as far as Shannon. You need to write an expression for the distance that Jane ran. So you've got to, again, figure out what the variable is. In this case, D is the variable that's given to you. You need to know the number involved, and this one says 1/3, which is 1/3. And then you need to figure out the operation. That can be a little tricky. In this case, you can always, if you get stuck, put in a number for D. If you put in, say, 100, it's going to start making sense, because to go 1/3 of 100 makes more sense than saying 1/3 of D. 1/3 of 100 is clearly 33. So then it starts to come together. Of is times. So this is going to be 1/3 times 1/3 D is the distance that she ran. And as soon as somebody gives you a value for D, then you're going to be able to give them an answer. Okay? So this is a boxed final answer there. That's it for this little blurb.